Alrighty, now let's see question number 7. What is the time in the air of an object thrown up at 22 meters per second? So you throw the object up. Let's assume you start at this level. You throw it up. Is it going to stay in the? No, it's going to come back, guys. When you throw an object up, it's going to go up and then come back. Okay, so that's the path of the object. And if you draw a motion diagram again, it's going to slow down while it's moving up, and it's going to speed up when it's coming back. The spacing between the dots would decrease, and then it will increase. And at the maximum height level, Vy at max height is equal to 0. Okay? So we also know that the acceleration Ay is always negative 9.8 meters per second squared, and then time is an unknown. We know the object is thrown at 22 meters per second, so initial velocity v0y is equal to 22 meters per second. It's positive because we take up as positive y. That's why we have a negative acceleration and positive initial y velocity. And the time taken to reach the ground. We are asked to find the total time. What is the time the object is in air? If we can solve for the time taken to reach the maximum height, 2 times that would be the total time the object is in air, because it takes the same amount of time for the object to move to the top and then come back to the bottom. So from here to here, if you know the time t, the same amount of time would take for the object to move from top to the bottom. So total time would be 2 times t. I'm going to solve for t first. I'm going to take this as my initial point, as the this is my initial, the point where you throw the object. And at that point, I know the initial velocity. You can label the initial height as 0 because that's the ground level. And then final point, Vy. This is the final point. I know the velocity is 0, and I also know that the time t is t and acceleration is negative 9.8. So let's use the first equation and see whether I can solve for the time taken to reach the max height. Vy is equal to v0y plus acceleration times time. Final y is 0, initial is 22 meters per second, acceleration is negative 9.8 meters per second squared. Yes, there's only one unknown, that is the time. And if I subtract 22 meters per second from both sides, I'm going to end up of getting, you can see you have a positive sign and a negative sign. That's just a negative, right? And you can cancel out these two, and now you can divide both sides by 9.8. So negative 22 meters per second is equal to negative 9.8 meters per second squared times t. Divide both sides by negative 9.8. Divide by negative 9.8. And when you do that, so you don't have to wait for me, guys, you can solve for it. Cancel out. 22 divided by 9.8 is 2.24 seconds. I just rounded it off to 3 significant figures. So if you look back what I did, I have the diagram started with initial velocity 22. You throw the object up. Okay, so initial velocity 22, reach to the max height, come back. So from here to here, the time is t. So I used my kinematic equation, and I know at the maximum height level, velocity is 0. And I get the time as 2.24. This is just the time taken to reach the max height. So total time the object is in air is 2 times this 2t. So 2 times 2.24 seconds, that would be equal to 4.48 seconds. Okay, so that's the total time the object is in air. Alrighty. Okay, so now let's do the last question, number 8. What is G on Mars if a ball dropped from 4 meters takes 1.47 seconds to hit the ground? So if you're wondering what this G is, this is the acceleration due to gravity. On Earth, this is negative 9.8. But if you go to a different planet, it's going to be different than 9.8. Why? Because this acceleration due to gravity depends on the dimensions of the planet, depends on its radius, mass. So it is not the same for a different planet. So for Mars, if you're going to do the calculation, let's first start by drawing a diagram. So you drop the object, meaning initial velocity is 0. So let's assume you are in Mars and you go there and drop the object. Initial velocity is going to be 0. Let me write it down. And it's going to speed up. Same thing. It's going to have a constant acceleration. All the conditions, all the equations we learned so far valid. If we make the assumption as the air resistance to be 0, if air resistance is 0, the kinematic equations can be used because these equations are valid for uniform acceleration conditions. So the time t is equal to 1.47 seconds. So it is dropped from 4 meters. Final y position is equal to 0 because it reached the ground or the bottom level. Acceleration ay is an unknown now. Okay. Alrighty. So we are asked to calculate the acceleration g. So I'm going to just write down the first equation. Dy is equal to v naught y plus acceleration times time. I don't know the final y velocity. I don't know the initial is 0. I don't know the acceleration. I know the time, but there are two unknowns, so this is not going to help us. Let's write down the second equation. I do know the final y position is equal to 0. I know the initial, it's 4 meters. Initial velocity is 0. Time is known. Acceleration is an unknown. Time, we know the time. So there's one unknown, that is the acceleration. Now we need to solve for the acceleration, right? So let's see how we can do that. Final y position is 0. Initial is 4 meters. Initial velocity is 0 plus half times acceleration on Mars times t is 1.47 seconds. And you have to square. That's my seconds, guys. Yep. So that's it. Now we have to simplify this. 0 is equal to 4 meters plus half times ay times 1.47 squared. So if you take 1.47 and if you square it, you get 2.1609, and if you divide it by 2, you will get 1.08045 AY. I multiplied I square 1.47 and then I multiplied by 1.4 and this is what I get. And I'm trying to solve for AY, so I have to separate it on one side, subtract 4 meters from both sides of the equation. And if I do that, I get AY is equal to negative 4 meters divided by 1.08045. This is in second squared, guys. Didn't put that there. Second squared. Okay. So AY is equal to 4 divided by 1.08045. You get 3.7 meters per second squared. Don't forget the negative sign because we always take up as positive. I should actually mention it here. So I'll go here and put we take up as positive. Why? That's why we have a negative acceleration. We got a negative value for the acceleration, negative 3.7 meters per second squared. Okay, so it's directed downwards. So that's it.